This crab carries a living, stinging animal in each claw. Not a shell, not a tool it made. A living creature held deliberately, never set down. Off the shallow reefs of the Indo-Pacific, in water warm enough to feel like bathwater, marine biologists first documented the behavior formally in 1902. James Owen Duerden crouched over collected specimens and recorded something he couldn't categorize. A crab barely the size of a thumbnail, gripping a sea anemone in each dactyl. The claws had been modified so precisely for this purpose that they could hold the anemone without crushing it. The crab is Lybia tessellata. Described first by Henry Milne Edwards in 1867. Smaller than a coin, no shell thick enough to matter, no venom of its own, no claws sharp enough to cut through anything worth cutting. By every metric that determines survival on a coral reef, it should not last a day. And yet it raises both claws when threatened. Anemone tentacles fan outward, nematocysts loaded and ready, and predators reverse direction. A reef fish drifts close. Both anemone weapons swing toward it. The fish leaves. Every time. The anemones are not decorative. They are functional, loaded with stinging cells the crab itself cannot produce. Schnytzer et al., writing in Zoo Keys in September 2017, described the motion precisely. The crabs wave the anemones in a manner reminiscent of a cheerleader's pom-poms, hence their common name. Pompom crab. The name sounds gentle. The biology is not. What makes this stranger than simple tool use? The crab never releases them. It feeds with them. It moves with them. It has been observed using the anemone tentacles to scrape food particles off rock surfaces, then picking the debris off the tentacles afterward. The weapon also functions as a fork. But the real question is what happens when one disappears. A 2013 laboratory experiment by Yisrael Schnytzer at Bar-Ilan University documented exactly that scenario. And what the boxer crab did next will redefine what kind of relationship this actually is. The easy explanation writes itself. This is tool use. Crabs carry things. Hermit crabs drag shells across the seafloor. Decorator crabs press sponge fragments onto their own bodies, piece by piece, until they disappear into the reef. Tool use in crustaceans is documented, peer-reviewed, unremarkable. So the boxer crab picks up a stinging animal instead of a shell. Clever variation. Case closed. Except it isn't. Here is where the explanation breaks. Yair Etchitov at Bar-Ilan University co-authored a 2013 study examining which anemones boxer crabs actually carry. The answer was not whatever stings. The answer was almost always one species. Triactes producta. The same animal. Every time. That matters because Triactes producta is nearly absent from the open reef. Marine biologists running transect surveys, counting species along measured rope lines, find it rarely clinging to bare rock, tentacles pulled in. It is not common. It is not easy to find. And yet every documented wild boxer crab carries it. Not a substitute. Not a different anemone. This one. Schnytzer et al. Tested what happens in captivity when the anemone is removed. The crab searched continuously over bare glass, over substrate, over coral rubble. It did not pick up a sponge fragment. It did not carry a shell. It did not stop. As Schnytzer's team recorded, crabs deprived of anemones were observed to steal anemones from other individuals during agonistic encounters. They fought other boxer crabs to get the right animal back. Not any animals. That one. This is not opportunistic tool use. A hermit crab will use a bottle cap if the shell supply runs dry. The boxer crab refuses every alternative on offer. So if this isn't a crab picking up whatever stings, if it requires a specific living species, pursues it, fights for it, then what exactly is the relationship between this crab and that anemone? Here is what the experiment actually showed. In 2013, Yisrael Schnytzer and his team at Bar-Ilan University placed boxer crabs in individual laboratory tanks. One crab, one anemone. They removed the second deliberately. The crab did not adapt. It did not substitute. It did not go without. It tore the remaining anemone in half. Not randomly, not in distress. The split happened at the oral disc, the precise anatomical division point that allows cnidarians to regenerate. Schnytzer's paper, published in Peer J. Volume 1, documents this in every tested case. Every single one. When a crab loses one of its anemones, the study states it tears the remaining anemone into two pieces. Both pieces regenerate into complete anemones within a few weeks. The crab knew the cut. That is the moment this stops being tool use. A tool does not have a correct seam. A tool does not regenerate if you split it wrong. The crab performed a surgical division on a living animal, and the living animal survived it because the crab got the angle right. Then the harder question. Marine surveys of reef systems have turned up something that took years to register as significant. Triactes producta, the anemone species these crabs carry, shows no evidence of sexual reproduction in the wild when paired with boxer crabs. None documented. No larvae. No independent colonies forming. The boxer crab has become the anemone's only reproductive mechanism. The only way it multiplies is to be torn. The crab does not serve the anemone. The crab controls the anemone's entire existence, its movement, its feeding, its reproduction. Every generation of that anemone alive today passed through a claw. We called this mutualism. Two partners, mutual benefit, mutual autonomy. But one partner cannot reproduce without the other's intervention. One partner has never been set down. The archive does not have a cleaner word for it yet. Filed. Unresolved. The question stands.